Welcome. Hey friends, how are you doing? All good? Sleepy? No? Little bit? Third day? Getting tired, right? Getting there. Cool. One more day. So let's talk about LLMs and AI. I'm kidding. No. So let's talk about a passwordless feature. So I'm Deepu. I'm part of the JHipster team, Java champion, yada yada. Do a lot of open source, polyglot developer, developer advocate, the standard stuff. So why passwordless? Why do we even have to go passwordless? We have been using passwords for thousands of years, right? It has been fine to an extent. It's quite easy sharing Netflix passwords, Amazon passwords, those kind of stuff. It's convenient. So why do we have to get rid of that? Huh? So there's something called a password problem. So Verizon publishes this yearly report called a Data Breach Investigations Report, and according to this year, 60% of all breaches that was analyzed had something to do with credentials or passwords. Right? And the year before it was 65%, the year before was 70%. Though there is a trend in things getting better, that's still a lot, right? 60% is a lot that has to do with passwords. So if we can get rid of passwords, we get rid of all the 60% of issues, right? That would be ideal, right? So I don't think password is the problem per se. I think it's a human problem. I think as a species, we are not evolved enough, or we are not smart enough to use passwords properly, right? So most of the password problems, or the problems that we assign to passwords, are human problem. We are the weakest link most of the times, right? So passwords rely on humans to do a lot of things that we are not good at. It expects us to keep them safe, create complex passwords, remember a lot of things. We're not that good at any of this, and history has proven this a gazillion times, right? So it's more of an us problem than the technology or passwords itself. So the issues, if you have to dive into the issues, there are it's multifold. So let's dissect a bit, and also look at all this from a layman's perspective, not from an IT person's perspective, right? So we are all in the IT industry. We know certain things. We know best practices. So think of it from people who are not in IT, from their perspective. It's a much bigger issue, right? So passwords are knowledge-based. That means you have to remember them. So it relies on us to remember them, which means we cannot remember a lot of complex passwords. Maybe some people can, but most of us cannot. How many of you can remember, let's say, 10 complex passwords? Wow, okay, quite a few people. Not bad. 5? 3? Yeah, that's the maximum I can do. And if we make passwords complex, they're hard to remember, then we have to rely on password managers and stuff like that, which is again okay for us. But imagine people who are not in IT. As long as, if a password manager is built into their browser and if it is nicely prompted every time, they might use it, but otherwise they're not going to care. And if we don't do complex passwords, then it becomes easier to guess, easier to hack into. So there's all these knowledge-based issues. And also, password being knowledge-based results in social engineering. In a lot of high-profile breaches, if you dig deep enough, you'll see it was someone being socially engineered. And in many cases, it's not that difficult to do that. I think there is a popular video on YouTube where someone plays baby crying on the background and calls up this employee of a phone company or something. They almost give up a password for someone else because you emotionally manipulate them, do all sort of things. Social engineering is not that difficult. So password being knowledge-based results in all these issues. And another issue with, again, password being password is phishing, right? So many of us might have fallen for phishing. Even if you're very tech savvy, there are really smart or complex phishing scams out there that some of them are very ingenious. I recently heard about a phishing scam from the booking app. So it resulted from a genuinely registered hotel in the booking app. So it looks so genuine. So it's hard to distinguish. Then we have, again, because of passwords, you can remotely access something. So, if your passwords are stolen, which is a huge market, right? Stolen passwords are a huge market. Apparently, you can buy a set of passwords for $10. It's that cheap. Uh, Someone can access your account from another continent, and unless you have MFA or some sort of mechanisms to alert you, you wouldn't even know. And only recently, at least all these big systems like Google or Facebook or whatever, it has become smarter to alert you when someone is trying to access your accounts and these kind of things. But it's only a recent thing, right? So remote replay is another big issue because of passwords. And again, since we are using passwords, we have to store them somewhere. And storing passwords in our backend, in our database, makes the database target for hacking because, again, stolen passwords are a big market. So if you get hold of a set of passwords, you can sell them in the dark web. So, by storing passwords, we are making our servers more, attractive to hackers. Which is another issue. And because of that, we have to do a lot more to secure our servers because we are storing passwords. Then again, you can reuse passwords, which is a big issue. You can share passwords, big issue, writing it on sticky notes and those kind of stuff. So all these, again, because passwords are passwords. And finally, on the back end, on the development side of things, right? Because we are storing passwords, we have to do more things, like we have to salt and hash them, and we have to encrypt our databases. We have to have additional security policies in place, and in most bigger companies and enterprises, you have to have additional, auditing and these kind of things in place. So it brings in a lot of complexity. It kind of makes you a broader target. And of course, we have to build recovery flows, reset mechanisms, all this kind of stuff. Apparently, a password reset costs an average of $70 or something, when you factor in everything. So that's a lot we spend on passwords, right? So obviously, if we get rid of passwords, these issues should go away, right? Of course, it's not that we didn't try, right? We have different kinds of passwordless mechanisms already. We have biometrics, we have magic links, we have OTP-based systems where you don't need passwords, but you always get an OTP to sign in. We have push notification-based authentication. They solve some issues, they make some issues better, but none of them solve all of these issues. None of them are leaps and bounds better than passwords, right? And this is where passkeys come into the picture. So passkey is a unique cryptographic key pair that allows you to access online services or allows you to authenticate yourself. It's based on asymmetric public key cryptography. And in my opinion, a passwordless feature is what passkeys is offering, or it's where we are going towards. So how many of you have already used passkeys with any services? Nice. A lot of services already provide support for passkeys. GitHub, Google, they all probably already got prompts to set up passkeys from one of these services. So if you have gotten the prompt, try it out. It's much more convenient. So this also kind of takes away the need to use password manager. I'll come to that in a bit. Now, how many of you are password managers for someone you know? Like a family member or someone? Great, I'm password manager for my parents. So I maintain their passwords and everything. I'm pretty sure a lot of you are in similar situation, or a lot of you have encountered something like that, right? So it's not easy for the general public, password managers and these kind of things. So before we dive deep into passkeys and how it works and what it offers, let's briefly talk about some of the underlying technologies which makes it easier to understand the remaining. So first, of course, is public key cryptography. So asymmetric public key cryptography. So it's a pair of mathematically linked keys. You have a public key, which is public, you can share it widely. You have a private key, which needs to be kept secret. And these keys are uniquely linked to each other and can verify that they belong to each other. It's hard to spoof them, right? So that's. And we have two purposes, two use cases for public key cryptography. The first one is encryption, of course. So if you have someone's public key, you can encrypt a piece of data using that, and only the person with the private key can decrypt that. So that's the standard encryption use case. And we can also use the same set of key pair for signatures, digital signatures. So if you have a private key, your private key, right? You can sign a piece of data using your private key, and you can send that data to someone. And since your public key is public, everyone have access to that, right? So anybody who has access to that can verify that this piece of data is indeed coming from you because it is being signed by your private key. So only you could have signed it because only you have your private key. And this is how digital signatures, PDF signatures and stuff works. So it's much more trustable than even like hand signatures because of cryptography and stuff. So, and this is the mechanism that we use for passkeys as well. And the next piece of the puzzle or next piece of technology that makes passkeys possible is an authenticator. So an authenticator is a hardware or software entity that can create and store public key pairs. So these key pairs, of course, we can use the same device for registration, authentication, and most of you have an authenticator. Even if you don't know I'm pretty sure every one of you have an authenticator. A device, authenticator device. So there are two types of authenticators. We have platform authenticators. So platform authenticators are built into a device, right? So Touch ID, Face ID, your TPM chip on your laptops, the fingerprint mechanism, and it's the TPM modules on your Android phones. These are all platform authenticators because you cannot remove the authenticator from its platform, right? Windows Hello, all these things. Then we have roaming authenticators. So roaming authenticators are removable devices which doesn't have to be attached to a particular platform. So these are devices that you can use with any devices or any platform. They are generally attached using USB, NFC. Sometimes it also uses Bluetooth for some stuff. Come to that later. For example, YubiKeys. How many of you are familiar with YubiKeys? I'm pretty sure some of you got YubiKeys from us these days. There is Google Titan. There are many other vendors who provide security keys. These, security keys are considered golden standards of security. I'll come to that later, why they are so. And how many of you don't have a roaming authenticator? I'm sure you have a roaming authenticator. So your smartphone is also a roaming authenticator. So you can use an Android or an iOS device as a roaming authenticator. So next standard that makes passkeys possible is FIDO. So FIDO is a standard from Fast Identity Online. It's a community of security companies and experts coming together to kind of get rid of passwords and move all of us over to the fabulous world of asymmetric public key cryptography. So that's a goal. But FIDO comes up with the standards that makes passkeys possible. So specifically, FIDO 2 is the current standard that makes it possible. And FIDO 2 is made up of two other standards. The first one is Web Authentication, which is a W3C standard. And then we have another protocol called Client to Authenticator protocol. So these together forms FIDO 2. So Web Authentication is a W3C specification. So it provides you with a set of JavaScript APIs which you can use to talk to authenticators, platform or roaming authenticators. WebAuthn underneath might be using browser's credential management API, and in terms of, in case of mobile devices, whatever credential management API that particular platform offers. So WebAuthn consists of three main actors. So we have the authenticator, as we saw. So the authenticator is responsible for creating key pairs and also saving private keys. It can also have some metadata and stuff like that. Then we have a relaying party. A relaying party is nothing but a server or a backend that requires authentication. So it can be your own server implementation like a Java server, or it can be an IDP like Auth0 or Okta. So the relaying party in this case is responsible for saving public keys, whatever other metadata it requires. And in case of MFA, it could also be storing encrypted private keys. Then we have a client. A client consists of the user and the browser. So the user is there for providing consent and stuff. The browser is responsible for making communication possible between the authenticator and relaying party. So the browser is responsible for being the middleman for this. So the client to authenticator protocol is required just for the roaming authenticator part, right? Because if we look at the architecture, the browser or web authentication, WebAuthn API can actually talk to platform authenticators using the platform auth API from the operating systems. But it cannot talk to roaming authenticators, and that is where CTAP2 comes into picture. With CTAP2, web authentication can talk to roaming authenticators via USB, NFC, or Bluetooth. So these are the underlying technologies, and so coming back to passkeys. So passkeys, like longer definition, longer technical term for passkeys would be discoverable passwordless FIDO credentials. That's a mouthful to say, so passkeys are better. Passkeys are considered a noun now, same as passwords. So it used to be called FIDO multi-device credentials some time ago. It's an evolving thing, so things keep changing. But for now, this seems to have standardized, at least for the naming bits. Passkeys have two variants, right? So we have synced passkeys. So synced passkeys are something that would be more like easier to use for the general public or for mass adoption, because synced passkeys have the private keys synced between your devices in a specific ecosystem. For example, if you're in the iOS ecosystem, and if you create a synced passkey on iOS, on your, let's say, on your MacBook, when you go to your iPhone, logged in with the same Apple account, you would automatically have this passkey synced to that device as well. So the platform takes care of syncing this passkey or copying the private keys across the devices, so you can access it from any of the devices in the same ecosystem. Of course, it's end-to-end encrypted and everything, and so Apple, I think, it stores it in your iCloud keychain with your iCloud account, linked to your iCloud account. Similarly, you can have the same kind of experience in the Google ecosystem using Google Password Manager. So if you're logged into Chrome using a Google ID, when you create passkeys on, regardless of the machine, wherever you are logged in with Google Chrome, you will have that passkeys synced there. Similarly, if you don't want to use any of that, you can use most of the password managers also provide syncing passkeys as an option. LastPass, Bitwarden, OnePass, all these, they all provide similar features. You can use any of them. So sync passkeys offers better usability because it's easier, more convenient. It only requires one-time enrollment, so you enroll in one device and you get that synced to all devices in the same ecosystem. It provides that means you automatically get some sort of backup mechanism. So even if you lose all your devices, if you still know your account and if you can still access your account, when you add a new device to the same account, let's say Apple account, the passkeys get synced. So you can restore the passkey. So there is a restoration mechanism built in, so you don't have to worry about backing up and these kind of things. But which comes, all this niceness comes with slightly less security, because sync passkeys are slightly less secure than the other variant, which is device-bound passkeys. So that brings us to the next variant. So next is the device-bound passkeys. So device-bound passkeys differs from sync passkeys in terms of how private keys are stored. In device-bound passkeys, the private key doesn't leave the device, the authenticator. So if you're, let's say you're creating a passkey using a YubiKey, your private key will only live in that particular YubiKey. It will not go out of that. Same goes for whatever device you use. So that's the biggest difference, which means it is not as convenient as sync passkeys, because if you lose your YubiKey, your private key is gone. There's no backups. Each device needs enrollment, so in order to have backups, you might want to add multiple YubiKeys to the same account so that you have something as a backup. So no recovery and backups, again, because it's the same. But that means this is the most secure option, and security keys are considered gold standard of security, right? So which means device-bound passkeys are the most secure option if you are using passkeys or any sort of asymmetric authentication, public key authentication. So this doesn't mean that you have to use, let's say, you have to stick to one or the other. For example, I use YubiKey for most of this stuff because I'm on Linux. I know you'll be like, hey, Linux. No, it's not the fault of Linux. It's the browsers which doesn't support that. But I can still use sync passkeys with my mobile phone as an authenticator. I'll show demo of that. And of course, with YubiKey, I still have YubiKeys, multiple YubiKeys registered for most services. there are good things and bad things. One bad thing is I tend to always forget my UB keys. So now I have multiple UB keys in every place possible, so that even if I forget one, I have something else somewhere else. So that's a downside, but that's only if you're someone like me. You can still use sync passkey. I said I'll show you a demo of that. So we'll come back to that. Let's move on and see how the entire flow actually works, or how the magic actually happens. So there are two flows for passkeys. We have a user registration flow, and we have a user authentication flow. So let's look at the user registration flow first. So to begin, you have a user. Let's say you go to a particular website. You click on register. So the client, in this case, the particular website, right? So the client needs a randomly generated challenge string in the first place. So the client requests the relaying party to provide a random challenge, and technically it has to be a random data, but in most practical uses, it's going to be a base 64 string or something like that. So the relaying party provides random data back to the client. The client can now call the navigator.credential.create method, which is one of the two WebAuthn APIs. It will pass the random data and other metadata like the domain, where the client is running, and username that needs to be used, and all this metadata. It will pass to that call, and WebAuthn, in this case, will ask for user consent. And depending on which authenticator you're using, it'll give you options. Web authentication always going to give you options between, if you have multiple authenticators, like for example, a fingerprint and a UB key, it's going to ask you to choose one. So you choose whatever you want, and you provide consent by, by either touching it or by scanning your face or with a fingerprint or whatever. Once you provide consent, the authenticator is going to create a new public key pair. So regardless of, so for example, if it is the UB key that you selected, then the UB key is going to create the key pair. If you chose something like, let's say, the Touch ID thing, I think Apple has something called Enclave or something, the TPM stuff, it creates the public key pair. And once the key pair is created, of course, with the private and public key, the private key is stored there. And in case of synced passkey situation, the private key is also synced to the whatever cloud infrastructure like iCloud or Google password manager or whatever, Bitwarden or wherever, is synced there. Then with the public key and some of the metadata, a CBOR encrypted object called attestation object is created. So this attestation object will have the public key created, unique credential ID for that flow, some other metadata like certificates used, what kind of authenticator was used, all these metadata. It's all CBOR encrypted, and this particular object is transferred back to the client. So now the client sends this data back to the server, which is your RP, or the relaying party. So at the server side, of course, you do some validations for the data that came in. You made sure that the challenge you issued matches the challenge that you received back and everything, to ensure that it's the same flow. There is no session hijacking and stuff. Once that authentication is done, now you can save the user into your database, and you only have to save the public key, which means we don't have to encrypt it, we don't have to hash it, we don't have to do anything special to save that piece of data, because it's a public key, can be public, right? And registration flow is complete with that. So now that you're registered, you can authenticate. So again, the user goes to the website to log in. The flow is pretty much similar. So the client is going to request the relaying party for a random piece of data. It will get a random piece of data, and the client is going to call the Web Authentication API. This time, earlier we called the .create method, and this is the second API. So now it is going to call the .get method to authenticate. Again, it will pass the challenge and the domain and all these metadata to the method. And Web Authentication will again prompt for consent. So depending on whichever device or authenticator you use to register, you would provide consent using the same mechanism. And when that happens, two things will happen. So first, based on the domain where you are doing this, only keys that are matching for that particular domain, only private keys that were created for this domain will get picked up. And then based on the username you chose, it will get filtered down to that, and then you get the private key for that particular username and domain. Of course, you're not going to get the private key out. I mean, this all happens within the authenticator. The private key is selected, and using the private key, the authenticator, of course, the additional step In case of sync passkey, and if it's a new device, you might be getting the private key from the cloud, but that's an additional step, not important for the flow. But for the flow, once the private key is selected, the authenticator signs the challenge that was passed and then creates a new assertion response. Earlier, it was the attestation response. Now is the assertion response. So the assertion response will contain the signed challenge, again, some metadata, the device used and all this stuff. Now, this object is passed back to the client by the Web Authentication API, and the client can now pass this back to the relaying party or the server. So now the server already has a user, with a public key, the username and public key. Now it got this object with signed challenge, right? And the server knows the challenge that it issued. So now with the public key and using the signature verification method, the server can verify that this signed challenge is indeed matching with the challenge that you issued and is signed by the private key belonging to the public key that you have stored in the database. So this is how you ensure that whoever created the registration, the same person or whoever is having the private key for that flow has done the authentication. So the user is authenticated. So it has many similarities with the standard password-based authentication flow, but the main difference is everything is done using cryptographic key pairs instead of like passwords, which is symmetric data. So now that we know how passkeys work and know what they bring, why, right? Why do we need? Some of it might be, some of it might, I might have already mentioned some of the whys, but let's go over them again. So we saw the issues with passwords, right? Knowledge-based, phishing, and these kind of things. So Passkey solves each of these issues. For example, passkeys are discoverable credentials. They're not knowledge-based. So passwords are something you know, whereas passkeys are something you have and something you are. So passkeys, by default, are two factors. In every case, there is something you have, which is one factor, and something you are, which is the second factor. So it could be your fingerprint, it could be your face, it could be a PIN that you type in. So there is always two factors. Of course, you can, there are customizations possible where you can kind of remove the second factor, but by default, it will have those two factors. So in most of the cases, you don't even have to remember the usernames when it comes to passkeys. It will be much more clearer when I show you a demo. So passkeys are discoverable. It's not knowledge-based. It's something you have rather than something you know, which is much more harder to hack in because somebody has to physically come to you to get that from you, which is much more difficult. So as I mentioned, unless you are forgetting your YubiKeys and stuff, you don't have to remember much when it comes to passkeys. Secondly, passkeys are phishing resistant, as in phishing depends on one key thing, right? Having a fake domain which looks identical to the original one and making us believe that that is the actual thing and making us enter our credentials. That is how phishing works. With passkeys, that kind of becomes impossible because when you are in a different domain, you are not going to get any of the keys out because the key pairs that are being generated and stored are tied to the domains where you created them. So if you go to Facebook, let's say facebook1.com or something, the browser is not going to give you anything there. You can't, even if you try really hard, you can't enter anything. And secondly, even if you somehow manage to invoke the passkey flow, you won't be sending private keys over. You are just going to send signed data over. So the possibility is extremely limited, and that's why FIDO claims passkeys to be phishing resistant because it's literally next to impossible to do phishing there. Again, because it's something you have, it is remote attack resistant. You cannot breach it from another continent or something. You would have to physically get the, let's say, laptop or the phone or a YubiKey in order to breach someone. So that makes it much, much more harder. Right? Again, it is breach resistant because you're not saving anything in your database that is sensitive. You're saving public keys. Public keys are public. You might as well just distribute them. Doesn't matter. So you're not saving any private keys or sensitive data. So that makes your server much less attractive to hackers. So it is technically breach resistant. And passkeys are also not reusable or shareable with a star. So technically you cannot reuse passkeys because for every domain it's going to create a new key pair. So that part is solid. By spec, passkeys are not shareable, but Apple somehow made them shareable. You can airdrop or I think you can airdrop a passkey or something like that. So that's out of spec, but Apple does let you do that. And finally, password management, right? Passkeys are easier to manage. For passwords, we need reset flows, recovery mechanisms, hashing, salting, encryption, all those stuff. Whereas for passkeys, you don't need most of them. You still need a recovery mechanism if you're supporting, let's say, device-bound passkeys, because device-bound passkeys don't have any sort of backup mechanism built in. So you have to provide a recovery mechanism to folks who might be losing their YubiKeys and stuff. But other than that, you don't need, let's say you don't need password reset flows and all these encryption and stuff like that. So it makes maintenance much more easier. And finally, passkeys are also cross-device capable. So it doesn't mean that if you're on the Apple ecosystem, you can only use Apple devices to sign in. You can also use Google devices. Similarly, with Google Chrome, you can use Apple devices. So there's a lot of cross-device compatibility, and also passkeys have a feature where you can use a phone as an authenticator for another device. It has some Bluetooth magic happening. It ensures that the device is within Bluetooth, I think 100 feet or something, within the Bluetooth range of that device where you're trying to sign in. It does all those magic, and it lets you use passkeys on a different device as well. So, which means we can compare passkeys with existing secure mechanisms, right? So of course, if we plot it against security versus usability, of course we have the standard password, which is highly usable. It's very convenient, but it's not the most secure. It's the least secure mechanism. Then of course, once we started figuring out the issues with password, the industry came up with conditional MFA. So you might be getting an SMS or email. It's much more secure, but it makes the convenience slightly less. It's annoying. You have to use another device, or you have to go fetch your phone for SMS or something like that. And then we have password plus OTP, or something like SMS, email, OTP, which is again slightly more secure, slightly less convenient, because now it is not conditional; it's mandatory. And then we have OAuth 2 based social login. It's much more secure because we are relying on the security of a proven platform. Let's say login with Google. We are going to trust Google to have a better way of protecting the identity than whatever we might be doing with the application. And it's also much more convenient because you probably are already logged in with that service. So you just say, hey, log in with Google, and you log in. So steps required are much less. And of course, assuming that whatever that OAuth 2 social login provider is secure, much more secure, and has all the security best practices. Then we have sync passkeys, which is slightly more or as secure as social login, I would say, and same or slightly better in terms of user experience. Again, of course, user experience is it's subjective. So someone might find that flow much better or slightly less worse, but I would still say this is the user experience of sync passkeys is much better than all the password options. Then we have a password plus FIDO-based MFA combination. You might have used this, like for example, it could be password plus your touch ID or something like that, or password plus YubiKey kind of second factor. Again, that is much more secure, but convenience-wise, probably it's only as convenience as password or even less, because you now need to have a second factor. And then finally, we have the device-bound passkeys, which is considered as golden standard for security. So this is the most secure way. But then again, the convenience or usability is questionable there. Of course, that doesn't mean everything is everything is great and everything is going great. There are issues, of course. Number one is operating system and browser support. Again, whenever a Web3 standard comes into the picture, this is bound to happen. So browsers are going to implement it slightly differently. The user experience is going to be different in different browsers. Operating systems need to support it properly. Your mobile operating systems need to support it. So when all these things mix, things becomes fragmented, and you can already see the difference in UX between, let's say, Firefox and Chrome, for example. And also, there are some confusion around the UX of passkeys. It's not the most straightforward UX, at least for now. So there are some rough edges when it comes to that. And another challenge is cloud vendor reliance. A lot of people, especially people who are very privacy focused or privacy minded, have a valid concern, I would say, that over reliance on, let's say, Apple or Google or Microsoft to save your private keys. So you are giving keys to your kingdom to these companies. Should we over rely on them to save, save and secure our private keys and stuff like that? So it's a valid concern, but if you're already using Google's password manager, I don't think it's much different. Saving your passkeys there as well. But for those kind of concerns, of course, one option is you could use something like Bitwarden or one of your favorite password managers for that. That's an option. But there is this concern. And enterprise use cases. I mean, how many of you here work for an enterprise? How many of have like really weird password policies and rotation policies? Yeah, I have had really weird password policies in the past for places I've worked. So there could be friction with these kind of things because you can't enforce those kind of things with Passkey. You don't really need those kind of things. You don't need rotation and these kind of stuff when it comes to, for most cases. So there will be friction with that. And one another impact, especially in enterprises, most enterprises might have policies against using certain services. Google might be blocked, Apple Cloud might be blocked. So when you have those kind of setup, you may not be able to use sync passkey. So there's going to be issues like that. Of course, in all those situations, you might still be able to use device-bound passkeys. And in my personal opinion, that's a perfect use case for device-bound passkeys because it's the most secure option. So enterprises can always give you YubiKeys to use for passkeys and stuff. Of course, make sure to use multiple of them as backup. And then finally, even though we don't need reset flows and stuff, but we still might need recovery flows, especially when it comes to device-bound passkeys. So these are the current challenges that we have. So let's look at some examples. So we have multiple ways to do passkeys in the Java ecosystem. So first is we can do a Spring Boot application and use an IDP. Of course, I'm going to use Auth0 because I work for Auth0. Auth0 is great. You all should be using Auth0. After this, you'll use Auth0. Probably not. So let's, I generally live code this, but yeah, I have 12 minutes. I think I can make it. So I'm going to create a bare minimum Spring Boot application. So as you can see, I use, oh, sorry, wrong screen. Somebody should yell at me, please. I would have kept going. So I'm going to create a base application. It has the web dependency and the Okta Spring Boot starter. So Okta Spring Boot starter basically configures Spring security, and it configures default OAuth 2 flows for Spring security. So I'm going to use these two. Again, sorry, wrong window. Where's my key mouse? Does anyone see my mouse? Yes. It's barely visible. Okay. That was fast. I expected it to be delayed for the Wi-Fi. Okay, I go into that. So I created the Spring Boot application. Now I need a IDP, right? So I'm going to use an Auth0 IDP. I already have Auth0 configured, so I'm just going to create an Auth0 application. So in Auth0, we call, we segregate things by something called applications. So it's technically one of your IDP. So I'm going to create this. Okay, now I need, what do I need? Okay, I need the domain, I need the client secret and the client ID. Of course, I mean, it's a throwaway application, so don't get your hopes up about getting my client ID and doing something with it. So, okay, let's create, I keep forgetting that I can look at it here. These are from old ones. I don't need them. Okay, I can use these. If I'm doing something stupid, please yell at me or something. Give me a pointer, please. I tend to do stupid stuff. So got my client ID. I need the client secret. I can barely see my mouse. It's so tiny here. I believe I copied the right ones. Let's see. And since it's a empty application, there's nothing there. Just a Gradle build file and some basic, I think, a main class. So I'm going to create a bare minimum possible controller. So it's the bare minimum possible controller. It has the root mapping. It prints hello with your username from the authenticated principle. So that's it. It's the bare minimum application possible. Ready? Start. If this works, that's how easy it is to use Auth0 in a Spring application. If it doesn't work, then I'll figure out something else to say. I think that's good. Okay. Localhost 8080. Yes, it worked. I am already logged in, so maybe I should log out. I think I'm going to do a private window. I should have logged out already. Yes. So it's going to, directly it takes me to the Auth0's login page because it's a default application. I haven't configured anything special there. So by default, when you configure the Okta Spring Boot starter, all endpoints are secured. So by default, I'm redirected to login or sign up. So I'm going to sign up here. And I'm going to put something like, okay, I'm going to put my email. Oh, yeah, sorry. Thank you. Yeah, thank you. See, I do stupid shit. Yeah, works. I was afraid for a second it doesn't work. Okay, now I can create a passkey. There are multiple ways I can do this. I'm going to use the cross-device thing that I spoke about. Demo gods. What did I do? What did I do? Damn, for a second I was like, nothing bad happened. Did I put in the wrong? No. Passkeys. Really? At the end should be okay. Let me open this up in a. Let me quickly check. Oh, things are so small here. Is it big enough? Is it too big? No worry, I have a backup if this doesn't work. I expected things to not work when you actually do it because when I tried right before, everything worked fine. So I was like, this is definitely going to fail. This looks fine. You mean here? No, there is no space here. That shouldn't. No, this is fine. For a Spring application, you can put it in the root. So technically you can use this almost like a .env file in other languages, right? You put this in your root and you exclude that in your git ignore and stuff. So similarly, you can put application properties on the root and ignore it in your, git ignore file. That's I would recommend that if you're storing sensitive stuff, put it on the properties file on the root of the folder, ignore it in git ignore, and use the standard properties file in the class path for all the other stuff. So this kind of overrides that. So it's been a couple of years since Spring had that, I think. Okay, back to my issue. Should I waste more time? Okay, I only have 5 minutes. I'm going to switch to my backup. Sorry about that. But that's how you create it. It ideally should work. It works most of the times, except when I am actually demoing. Sorry? No, it works. Normally, it works. I think I probably I copied the wrong client ID or something. That's most of the times that's the case. But yeah, no worries. I have a backup. It's the same thing. It's the same thing that will work. Definitely works because that it works. I know it works. I'm going back to localhost. Sign up. Create a passkey. I was too confident. I promise this worked. Okay, I have even more backups. I came prepared. Yeah, might be the Wi-Fi. Yeah, could be the Wi-Fi. But yeah, it pays. Anyway, I'll check that later. So this is my own backup. Sorry that didn't work. I need to check what happened. I'm pretty sure it worked. Just yeah, that works. This is my okay. Before this, I'll just proceed to show you this as well. In Java, you can do your own implementation, of course. We have 2 options. WebAuthn J, I highly recommend that library if you're in a sad state to implement your own authentication without using an IDP, then I recommend using WebAuthn J for passkey stuff, 100% FIDO2 compliant, supports all sort of attestation formats and stuff. It's used by Kicklock, supports passkeys, has great Spring security support. There's another option, Java WebAuthn Server, but then not 100% FIDO2 compliant, not as nice as WebAuthn J. So if you're into building your own auth kind of hellhole, then I recommend this. So passkeys with Spring, this is what I have there. This is the demo. So I built this demo using WebAuthn J. Please work. Should I do a sacrifice or something here? I don't have a blade to cut my hands or something like that. I hear that is normally required sometimes. I will register. It is too slow. I don't know how to make that bigger though. I don't think that gets bigger. This is too much pixels. So it gives me options. So I have already my phone linked to the Google Chrome thing. So Chrome provides me my phone as an option. But if you don't have that, then you would use if it's the first time, you could also just use this second option, and it will give you a QR code to link your phone and all sort of stuff. Of course, you can use YubiKeys and all that stuff, but I'm going to use my phone to demonstrate how you could do sync passkeys. So I'm going to get a pop-up here. To create a passkey, I'm going to click create. It's going to ask for my fingerprint. Done. It's created. So done. So a lot of things happen. So this is creating a passkey in my Samsung wallet via Google Chrome, via Android's credential management API. And you don't have to install anything for this thing to work. So if you have a iOS or Android device, this feature is built into the operating system. So you can use these devices to create passkeys for any application or any website that supports passkeys. So you can use your phone as an authenticator. You don't need a YubiKey or something like that. And this is going to be synced. Since you used your phone with an Android or iOS, whatever, it's going to be synced, and you can use it in other connected devices as well. So now I can sign in with the same. No, don't do that. Why do you do that? Why does this keep happening to me? Can you read that actually? I can't read that. Yeah, I did. I did. It got the callback, you see? Let's see, trying to refresh the page. You're all having fun, right? Watching me struggle with these? I hope it is fun, at least. It's not fun for me. Why? But why? Okay. Did someone see something which I'm doing wrong? Oh, come on. Let me see. Why? Now it works. So I don't know what happened there. So it is going to show all the passkeys that I have because I created multiple to test, so I have multiple here. The first one, okay, fingerprint. Yes, okay. Again, I don't know why that happened. Normally it doesn't happen. It's only when I do demos these things happen. So something I need to look into. Okay. What else do we have? This is so if you're interested in the WebAuthn demo, you can get the source code from here. I am being told my time is up. That's all I had. You can also do passkeys with Spring security. It's coming soon, and some resources if you like. And use Auth0. It will work when you try it. It only doesn't work when I do demos. I promise it works. If you come to my booth, I'll show you that it works. It only works in this setting. There's something here. Something here. Thank you.
All systems are nominal. Initialize Genesis sequence.